we are going to concentrate on solving absolute value inequalities. Now, the core concept for this is to make sure that your equation or your inequality is set up as a distance equation, just like we've done in the past. However, the only difference now is that there is an inequality. Okay, so make sure that your absolute value expression is isolated. So for example, if you want to solve the absolute value of ax plus b, which is less than c, and where c is greater than 0, we're going to solve the compound inequality where we're going to rewrite it as ax plus b is greater than negative c. Notice that the original was less than, and then you had to reverse the sign and make sure that our c is negative. And I'm going to be showing you like how do you know if it's an and or. And we also have ax plus b is less than c. And from there, you're able to solve the compound inequality. So we have to rewrite absolute value inequalities as compound inequalities in order to solve. So if you have the absolute value of ax plus b is greater than c, where c is greater than 0, then we're going to set up a compound inequality. In this case, it's going to be an or. And you're still doing the same thing. You have ax plus b is less than negative c. Notice that our inequality did reverse again. And over here, the other expression, ax plus b is greater than c, and that stays the same. Now, all this can be applied to if you had a less than, with less than or equal to, and greater than with greater than or equal to. We're going to go ahead and go through the notes. So I've already typed up the steps here. We're going to rewrite as distance inequality. We're going to rewrite as a compound inequality and determine if it's an and or an or. And 3, we're going to set up our 2 cases to solve and graph. So remember to always visually check to see if it makes sense or not. So I gave you this little icon to help you remember. So it says graph and solve, absolute value inequalities less than. That's your hint. If I was to read an example and it has the and in it, less than in it, then it's going to be an and, which is an intersection. So remember, we talked about it being an intersection. All right. Uh-oh. It moved. Hang on 1 second. All right. So it's an intersection. So ands are intersections. Don't forget. All right, so that means if I says and, I should see an intersection in the end. Okay, so let's go ahead and solve for this. So step 1, I'm going to isolate the absolute value expression before I set up my 2 cases. Okay, before I can determine if it's going to be an and or an or. Okay, so if I read this, I have the absolute value of 5n minus 7 is less than, so therefore it's an and 17. So I'm going to have 5n minus 7. And remember, you have to reverse the inequality if you're going to bring in the negative here. So it's going to be greater than negative 17. So these are the 2 things I've changed. Then we are going to have the word and that separates the 2. And we're going to have 5n minus 7 is less than 17. So now that we have our 2 cases, the absolute value inequality is now changed into a compound inequality that states that whatever happens should be an intersection. Okay, because that's saying that it's an intersection. Now, after this step, that's where you can tell if it's an and or. You can't tell at the beginning because sometimes if you multiply or divide by negative, it might change that. So just be careful. Wait until you have your distance inequality before you determine if it's going to be an and or an or. All right, we're going to solve. by adding 7 to both sides, and we have 5n is greater than -10. And then we divide 5 to both sides. So I'm going to get n is greater than -2. And let's go ahead and figure out the other one. Add 7. And so we get 5n is less than 24. And we're going to divide both sides by 5. So n is greater than -2 and n is less than 24/5. And now we are going to graph this. So let's go ahead and graph. So at -2 is going to be open circle, where n is greater than -2, so it's going to go in this direction. And n is less than 24/5, so 24/5 is about 4.8. So I'm going to do another color so that we can visually see this. So 4.8 is about 8 here, and it's an open circle, and it's saying it's less than. So where it intersects is where the solution is at. So your solution is in between -2 and 5. Let's take a look at the next example. So I still want to isolate the absolute value expression so that we rewrite it as a distance inequality. So to solve for this, I'm going to isolate the absolute value expression. So that's this expression here. Remember, we talked about the analogy about the fire and whatnot. So we want this expression right here to be isolated. So in order for me to do that, I'm going to multiply 8 to both sides of the inequality. And therefore, I'm going to get 3n, the absolute value of 3n, is less than or equal to 32. Now, from here, this is when I can say, is this an and or is it an or? So, and the only reason why I can figure that out now is because the absolute value is isolated. So in this case, I have less than as an and, okay, or less than or equal to 32. So I know that this is going to be an and. So here are my two inequalities. I get 3n minus 4. And remember, we were going to reverse the inequality symbol if I'm going to bring in the negative. So it's greater than or equal to a -32. The other one is, and don't forget to write your and, 3n minus 4 is less than or equal to 32. So we're going to go ahead and solve for that. So when solving, I'm going to go ahead and add 4 to both sides. I'm just going to move a little quickly. So I get 3n is greater than or equal to -28, and divide both sides by 3. And we get -28 thirds. On this side, we're going to add 4. And I get 3n is less than or equal to 36. Divide 3 to both sides. I get n is less than or equal to 12. So this is an and. So I expect an intersection. If it doesn't come out to be an intersection, so there might be a special case there. So let's go ahead and graph our inequality. And just zoom out a little bit so you can see. All right, so I'm going to go ahead and graph. I'm going to use the turquoise to graph that inequality, and the green one, I want to graph this one here. So then we can see if it comes out to be intersection. Now, negative 28 thirds is approximately negative 9.3, repeating. And so that's the reason why we like to keep as a fraction, but we can estimate that when we're graphing. All right, so I'm going to go ahead and graph this. So n is negative 28 thirds. So I'm going to be, so here's negative 8. So let's say it's about right here-ish. Okay, so it's going to be a close point, and it's going greater than. So it's going to go greater in this direction. All the way. We're just going to draw all the way. And then we have n is less than or equal to 12. So at 12 is going to be another close point, and it's going in this direction. So if we look at it carefully, we only want to know where the intersection is located. So on top of this, I'm going to highlight where the intersections are located. So the intersection occurs here. So now we can say that that is the graph that represents the intersection between negative 9.3 to 12. Okay, it's not a special case because if it was an or and it covered all, then that would be all our numbers. And in this case, we're just looking at where it intersects. Let's take a look at the ors. So we're going to do the same thing with or, but it says example 3, solve and graph your solutions. So we're going to do the same thing here, but remember, you can't determine if it's an or until you actually isolate and get it as a distance inequality. So I'm going to subtract 1 to both sides first, and I get 4 times the absolute value of 2x plus 5 is greater than 20. And you probably heard me say greater. Okay. All right. We're going to divide 4 to both sides, and we get absolute value of 2x plus 5 is greater than 5. All right. Now we have this isolated. Cool. We can determine if it's going to be an and or an or. So the absolute value of 2x plus 5 is greater, as in greater. Just a way for you to remember. So it's greater. So this is going to be an or. So your compound inequality that you're going to rewrite is going to be an or, meaning it's going to be a union. Okay. All right. So let's go ahead and set that up. So I'm going to go ahead and change my colors. And you know what? I'm going to do one as 2x plus 5 is less than negative 5. And the other one is going to be 2x plus 5 is greater than 5. And then we're going to go ahead and solve for that. Subtract 5. I get 2x is less than negative 10. And we divide. So x is less than negative 5. And this one here is going to be 0. X is greater than 0. So our answer for this one would be x is less than negative 5, or it could be x is greater than 0. So I'm going to go ahead and graph this down here. And I'm going to do this one in the purple. And let's do a different color so that we can distinguish the two. And this one I'll graph as red, and then we can figure out where they actually intersect. So at negative 5 is going to be open point, and it says it's less than negative 5, so the number line in this direction goes less than. Then we have x is greater than 0, so at 0 it's going to be open point, and it's going to go to the right. Okay, So that's a true statement. That's an or, right? It's saying all your solutions to the left of -5, and all your solutions is to the right of 0 or greater than 0. All right, let's take a look at the next example. If I can find it right here, example 4. So before we do anything, we've got to make sure the absolute value expression is isolated. So I'm going to divide 8 to both sides. So my absolute value of -8k minus 3 has to be greater than or equal to 5. Okay, so great TOR is an OR, so my compound has to have an OR in between, and one has to be a positive, one has to be a negative. So here we have -8k minus 3 is less than or equal to -5, so that's my case 1. Or it could be -k minus 3 is greater than or equal to 5. So then we're going to solve for these. Add 3 to both sides. So I get -8k is less than or equal to -2. And when we simplify this, look what happens here. You have to reverse the symbol again because you're dividing by a -8. So it's going to be k is greater than or equal to 1/4. Or let's go ahead and figure out the other option. Add 3. Let's have -8k is greater than or equal to 8. And look what happens again. We're dividing both sides by a negative. We're going to reverse the symbol again. So k is less than or equal to -1. Our solution states that your answer can be k is greater than 1/4, or k is less than -1. So I'm going to graph that. Remember, if it's an or, it should look like a union, not an intersection. But if it is intersection, then you include all. Okay, so let's go ahead and graph that. So k is greater than or equal to 1/4. So that's about right here, well, less than a half. And this is going greater than. So that's going to go in that direction. X is less than or equal to -1. So at -1, that's going to be a closed point, and it's going to go to the left of the inequality. Okay, we say it is an OR, it's a union, and it looks like a union. All right, so I want you to try the 5 examples in your notes right here. I'm gonna zoom out so you can see. So here are 5 questions on the right-hand side that I want you to practice for tonight.